Hello, everybody, and welcome back to Times Academy. Sorry, I have a little bit of a sinus infection, so I sound raspy and like a pirate. And because of that, I decided to have a pirate themed proof. So our proof starts off with let us prove that if n is an integer, then n squared is congruent to 0 mod 4, or n squared is congruent to 1 mod 4. So let us split these cases into even and odd, matey. First of all, let's consider n is odd. When n is odd, we can say that n equals 2l naught or l odd plus 1. Because of this, we can say that n squared equals 4l naught squared plus 4l naught plus 1. This means that we can factor out the l naughts and say that n squared equals 4l naught squared plus l naught plus 1. Let's now set arbitrary integer t equal to l naught squared plus l naught. This means that we can say n squared equals 4t plus 1. And from this, we can say that 4t equals n squared minus 1. Because of this, we can see that 4 divides 4t, and therefore 4 divides n squared minus 1. This means, through the definition of modulus, n squared is congruent to 1 mod 4. Now let's move on to the case where n is even. If n is even, we can let n equal to LE for L even, where LE is any arbitrary integer. We now see that n squared equals 4LE squared. Let us say that LE squared equals omega. Now we can say that n squared equals 4 omega, and we can see since 4 divides 4 omega, that implies that 4 divides n squared. And if 4 divides n squared, then we know that 4 divides n squared minus 0. And now that we have shown this with the definition of modulus, we can say that n squared is congruent to 0 mod 4. Therefore, we have proven that for every n, which is an integer, then n squared is either congruent to 0 mod 4 or congruent n squared is congruent to 1 mod 4. QED.